Welcome to Unit 3, Lesson 3. We are going to be going over radians, arc length, things of that nature, and let's just dive right in. Okay, converting from degrees to radians, all right? If I am given to degrees, yeah, I'll be okay. If I'm given degrees and I'm told to convert to radians, you just take whatever degree they give you and multiply it literally by pi over 180. Okay, and that's your radians. So convert the following angles into radian measure and write your answer in terms of pi into the nearest tenth. Yeah, I'll do that with maybe one of them, but after that, you'll understand what we're doing here. So I have my degrees, 120. I multiply that by pi over 180. Okay, that ends up with, again, this is 120 over 1. I multiply the tops and bottoms. 120 pi over 180. Now, you should reduce this, absolutely. Okay, my zeros cancel, and 6 goes into both of those. I end up with 2 pi over 3 radians. All right, now let me show you something. If you're one of these people who are like, oh my God, I hate reducing fractions, your calculator reduces fractions for you. Let me show you something here. And first off, highlighter, I love thee. Okay, just take your 120 over 180. Before I even canceled anything out, I had 120 over 180. Forget the pi. Pi won't reduce. It's irrational. So for one moment, let's just forget about our pi. That's just going to carry along. Our answer is going to be right there. So what I want, I'm going to show you that the calculator can reduce the numbers in the fraction, not the pi. And if you did not know, let me turn this on. I take 120 and I divide that by 180. And I hit math, enter, enter. And that reduces to 2/3 for me right there. Beautiful thing. And then all I do, again, is I just carry this pi along for the ride. And that's radians. This is in terms of pi. That's exact. Now, if they want it rounded to the nearest tenth, obviously they mean you need to incorporate pi. You need to calculate pi in. Because pi brings your decimal in. So I take 2 times pi in the calculator and literally divide that by 3. And I'm going to round that to the nearest tenth. So I take 2 times pi and I divide it. Actually, I'm going to use this because you should get in the habit of using your fraction, alpha y equals enter. Because otherwise, you might have to put parentheses around fractions. And if you use this fraction function, it separates the numerator and denominator for you. Okay, mathematically speaking, it will do the right process. It will do numerator first, then denominator, okay? So I'm just going to get in the habit of always doing alpha y equals anytime I have a fraction. 2 pi over 3. If I hit enter, I got this crazy, funky number. They want it to the nearest tenth. So it's approximately 2.094, blah, 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 blah. This is the tenth because the number after it is 5 or bigger. 2.1 radians. This is rounded to the nearest tenth. This is exact. I am not going to round every one of these to the nearest tenth. Okay. I am just going to figure these out in radians in terms of pi. And then if you want, you can round them yourself. But I showed you how it's done. All right. 45 degrees. I take 45. I multiply it by pi over 180. All right. That's 45 pi over 180. And 45 goes into 180, I believe, 4 times. So it goes into itself once. It goes into it 4 times. So I have pi over 4. That's radians. Bam. If you want to do the other two real quickly, go right ahead. Now, negative 270. Oh, I know what this is right now because I know how to graph my sine. Excuse me. Wow. That was weird. Anyways, I know how to graph sine, cosine, tangent from 90, 180, 270, and 360. But let's still do this. Let's multiply it times pi over 180. I end up with negative 270. Don't forget the negative sign over 180. and I still have my pi out here. So that is negative 3 over 2 pi, and that's in radians. Okay, because 3 pi over 2 is 270 when we graph trig. All right, this just so happens to be negative, so I want to make sure I keep it negative. 345. Ooh, this is going to be interesting. I'm just going to multiply that times pi over 180. So I've got 345 pi over 180. You know what? I think I know what that is, but I'm going to use my calculator to be sure. I'm going to say 345 divided by 180. And I'm going to hit math, enter, enter. 23 over 12. Oh, wow. So 23 pi over 12. Mister, I don't know if it would have ever been, and of course that's radians. I don't know if it would have been ever been able to reduce like that. It would have taken me a while. Well, use your calculator. It's not illegal to use your calculator. Anyways, there you go. Not too bad. How do we get degrees to radians? I take my degrees, all right, and I multiply them by pi over 180, and that will give you radians. Now, let's go the other way. Let's say I have radians, but I want degrees. Okay, well, I take my radians and I multiply by 180 over pi. I literally flip that. And that's what we're going to do right now. Let's convert the following angles into degree measure. So I take pi over 6 and I multiply it by 180 over pi. Oh, that's awesome. And when I say that's awesome, this is what I mean. Okay, most of the time you'll have a pi in your radians. Not all the time. You see, there's going to be an example where we don't have pi. Okay, but most of the time when we have pi like this, what happens? Top and bottom cancel. Boom, boom. There's no more pi. 6 goes into 180 30 times. So my answer is 30 degrees. Oh, this is simpler. I love it. I love it. So times 180 over pi. Oh boy, my pi's cancel. 3 goes into 180 60 times. So now I have 2 times 60. That's 120 degrees. Woo booey. Now, I do not have a radian, or excuse me, a pi in my radians. I have 1.92 radians. I still multiply that by 180 over pi. Well, this is over 1. I multiply my tops, and I multiply my bottoms. So I'm definitely going to use a calculator here. There should be something just under 360 on the top. So we have 180 times 1.92, and I hit enter, and I get 345.6 for the top here. So that is 345.6 over pi degrees. Now, that's an acceptable answer. If they wanted my degrees to the nearest tenth, I would have to go ahead and divide that out. I would have to take 345.6 and divide it by pi. And that would give me 100.007. So that's approximately 100.007, which we will just call 100 degrees. Because to the nearest tenth, that 0 will stay as 0. All right? So be careful. If there's no pi in your radians before you convert it, there's going to be a pi in your radians afterward, because you need to put one in to convert it. Okay? That does not go away. It cancels here because there was a pi there. Started off with a pi, it cancels. If there is no pi, it will not cancel. All right? And that's fine. That's how it works. It's exactly how it's supposed to work. All right, this last one. We have a negative. Big deal. We're still going to multiply it times 180 over pi. Started with the pi, so they cancel. Don't forget, we still have a negative sign up here, so I still have negative 1. Right? And 12 goes into 180. Oh, my God. How many times does 12 go into 180? 10? 15? Let's double check my math. 12 times 15, it's 180. Good. So 12 goes into 180 15 times. So I have negative 1 times 15, which is negative 15 degrees. Look at us. So converting between degrees to radians and radians to degrees, it's no big deal at all. So if I go back here, if I have radians and I want degrees, okay, if I want degrees, I multiply by pi over 180. If I have degrees but I want radians, I multiply by pi over 180. This one, I multiply by 180 over pi. Can't remember if I said that correctly, but it's flip. It's the same fraction, you just flip it, okay? Now, there is a shortcut way when you're going from radians to degrees. First of all, if I have pi and I want to convert that to degrees, I still multiply that by 180 over pi. What happens are my pi's cancel, and I end up with 180. So keep in mind that pi radians is 180 degrees. We just proved it, okay? If we have radians and it has a pi in it, I can just put 180 in for pi because pi is 180 degrees. So for example, if I have pi over 2, well, I'll just put 180 degrees in for pi because that's what pi is. 180 divided by 2 is 90. So that means pi over 2 is 90 degrees. So let's do that with these three right here. I'm just going to substitute 180 in for pi. 180 divided by 4, that actually is 45. So it's 45 degrees. Pi over 4 is 45 degrees. All right? Let's do it again. 180 is in for my pi over 10. That's 18 degrees. Pi over 10 is 18 degrees. And let's do it here. 4 times pi, which is 180 degrees, all over 3. Well, 3 goes into 180 60 times. Yep, that's right. And 4 times 60 is 240 degrees. Bam. So 4 pi over 3 is 240 degrees. That's all fine and dandy as long as you have that pi there. I cannot do that here because I do not have a pi. Okay, I have to multiply that times 180 over pi. But if I have a pi, I can do that. If I have a pi, I can do that. If I have a pi, I can do the shortcut by just substituting 180 degrees in. Substitute 180 degrees in for pi. And that's a neat little shortcut. Finding the cosine, sine, and tangent of a radian measure. Okay? So find the exact value of each of the following. All right, the first thing I am going to do is I'm going to change my radian to degrees because then I can use the unit circle and go from there and everything is happy and life is balanced once again. Okay? So let's go ahead and do this. Pi over 4, it's 180 over 4. That's 45 degrees. So this is really asking me for the sine of 45 degrees. And if I draw a set of axes, and I draw an angle that's 45 degrees, okay, and I draw a triangle, I now have a 45, 45, 90 triangle. That is 1, 1, radical 2. This is opposites. This is adjacent. This is hypotenuse. Okay? Sine is opposite over hypotenuse. So it is 1 over radical 2. Or we can say radical 2 over 2 if we want to simplify. All right? And in quadrant 1, all trig functions are positive. All right? Now I'm going to go through and do these 6. So if you want to, oh, there's only 5, I lied. If you want to pause this and do them and then check your work against what I'm about to do, go right ahead. All right? So here we go. 4 pi over 3. We just did 4 pi over 3. It's 240 degrees. But this is negative. So that's like saying the cosine of negative 240 degrees. All right? So what I'm going to do is draw my axis and graph my line. Okay, here's 0. This would be negative 90. This would be negative 180. This would be negative 270. Okay, so it's going to be in quadrant 2. Here, 240, it's slightly closer to 270. All right, that means this is 60 degrees. All right, and if I draw a triangle, I now have a 30, 60, 90. That's 1, radical 3, 2. Okay, cosine is adjacent over hypotenuse. So adjacent is my 1. My hypotenuse is 2. So it's 1/2. But let us not forget, students, okay, only sine is positive in quadrant 2. That means cosine should be negative. Bam. Shablamo. Number 3. Oh, love this one. I know this. This is the same thing as saying the sine of 270. That's a quadrantal angle, or it's just an even 90 degrees. Okay, here's 0 degrees, 90, 180, 270. Okay, if this were a unit circle with a radius of 1, this coordinate here would be 0, -1. That's my x and my y. Sine is always the y value. Cosine is always the x value. So that is -1 because it's the sine value, which is -1. I love it when they ask us to solve for 90, 180, 270, 360, 0, because those you don't have to draw any triangles. You just have to count to 1. Fantastic. Now, here we go. Ooh, 5 times pi. Pi is 180 over 4. 4 goes into 180, 45. Yeah, 4 times. I almost said 45. No, wait, divided by 4. It is 45. I'll be okay. Sorry about that. And if I multiply 5 times 45, I get 225 degrees. So they're really asking me for the tan of 225 degrees. All right. I'm going to draw my axis and my angle. Okay, 0, 90, 180, 270. All right, 270 is more than 225. And okay, so 225 is going to be right in between. If I draw this angle, that's 225 degrees, okay? Which means my reference angle is 45. Nice. Which means we have a 45, 45, 90 triangle. It's 1, 1, radical 2. All right? Tangent is opposite over adjacent. Opposite of 45 is 1. Adjacent is 1. It's 1 over 1, which is 1. Is it positive or negative? Oh, students, take calculus. Tangent is positive. Tangent should stay positive. Super good. All right, we're on to the last one. Now, don't let this intimidate you, okay? -5 times pi, which is 180, over 6. Divide out first. Simplify first. 6 goes into 180 30 times. 5 times 30 is 150, and a positive times a negative is negative. So they're really asking you for the sine of -150 degrees. All right? That really was a lot better than you thought it was. Okay? It wasn't going to be so bad, children. So -150, here's 0, -90, because negatives go in a clockwise motion. -180. -150 is in between those two. So if I start here, it's closer to 180. I don't know, something like that. From here to here, it's -150, which means my reference angle is 30. I have a 30, 60, 90 triangle. That is 1, radical 3, and 2. All right, sine is opposite over hypotenuse. Opposite of 30 is 1. Hypotenuse is 2. Let's check. Oh, students, take calculus. They want sine. Tangent is the only positive here. Sine and cosine are negative. So my sine should be negative. Bam. And you know what? Just for poops and giggles, let's put the sine of -150 degrees in the calculator and see if it gives me the same thing. Okay? So the first thing I want to do is I want to go to mode and make sure I'm in degree mode. By default, I'm on radians. I'm going to hit degree. Right? So I'm going to hit sine. I've got to put negative 150 in there. So it should be negative 1/2, right? And there you go, negative 0.5. So if I wanted to change that to a fraction, negative 1/2. There you go. We're good. We're good at what we do, buddy. Oh my God. Central angles and lengths of intercepted arcs. Okay, in case you didn't know, an intercepted arc, that's this right here. That's the arc that is inside my central angle. My central angle is this thing right here, okay? Central angle is an angle where the point of the vertex is right in the center of the circle. The intercepted arc is the arc that the angle makes around the circle, okay? So, for a sector of a circle with a radius r and a central angle measured theta, which means the radius could be any number. We're just going to call it r. The angle could be any angle, 45, 270, 13, 68. It doesn't matter. We're just going to call it theta, okay? But as long as your degree is measured in radians, then the length of this arc, the length of this intercepted arc is going to be s. And how do you figure that? My arc is going to equal, it's right here, my angle times my radius, and that's it. Just make sure that is in radians. That's all you need to do. And it's just that simple, okay? Right, find the lengths of S and B in the given diagram, rounding to the nearest tenth. Okay, if we're rounding, that means we've got to multiply our pi into our equation, all right? So let's start out with S. That's going to equal my angle times my radius. The radius is 3 inches, okay, and the angle is 5 pi over 3. So that's going to be 5 pi over 6. I'm sorry, did I say over 3? Times 3. Okay, that's the same thing as saying 3 over 1. If I want to do this algebraically, 3 goes into 6 twice, and I end up with 5 pi over 2. And that's in inches. You see that? So this would be in inches. This is exact. However, round to the nearest tenth. So that means I'm going to have to actually put this in the calculator and do the math. Okay? Alpha y equals, enter, 5 pi over 2. And that's 7.853, we'll call it. 7.853. Is that 5.8 or 8.5? 8.5. So if I round that to the 10th, that's 7 point, that will round up to a 9, and that's in inches. This is how they asked us. This is exact. Please answer how they ask you. I'm just showing you what exact looks like. All right. Now, B, that still equals, that's still an intercepted arc. Okay, it's still r times theta. So my radius is still 3, but my angle is 2 pi over 3. 2 pi over 3 times 3. These 3's cancel and I end up with 2 pi. Okay, that's exact, but that is 2 times, I know pi is 3.14. I know if I double it, it's 6.28. If I round to the nearest tenth, 6.3 inches. Bada boom, bada bing. Oh, yay, a word problem. Okay, it's good. That's good. All right, let's draw a picture because I'm always good at pictures here. Find the arc length of a central angle of the sector is 225 degrees and the radius is 4. You really don't even need to draw a circle, okay? You really don't even need to draw a circle, but I'm going to. Bada boom. I don't care if it looks real or not. My angle is 225 degrees. I don't care if it's the scale. My radius is 4. They want this. S is going to equal my angle times my radius. But I want this in radians. So I'm going to take 225 and multiply it times, oh my God, pi over 180. So I got 225 over 180 pi. And if I have a calculator, I could take 225 divided by 180 and hit math, enter, enter. and that's 5 over 4. Okay, so that's really 5 pi over 4. This equals 5 pi over 4. So this is 5 pi over 4 times my radius, which is 4. All right? And they don't tell me to round it, so I'm going to say these 4's cancel. It's 5 pi inches. That's what S equals. How do I know it's inches? My radius is in inches. Bam! Sweet. Easy. Find the central angle of a sector of a circle if the arc length is 6 and the radius is 2.5 feet. Okay, so we still have this kind of circle thing here, and we have some angle. They tell me that the arc length is 6, so my S is 6. They say the radius is 2.5. 2.5, it's my R. They want me to find the angle. Okay, I still use my equation here, but this time I have my S and my R. Oh, that's just still a one-step solution, you crazy, crazy pants. If I divide this side by 2.5, and I divide this side by 2.5, it's 6 over 2.5, and that's in radians. Okay, and if I wanted to reduce that, mister, I'm terrible. Let's take 6 and divide it by 2.5. Okay, you get 2.4. That's 12 over 5 or 2.4. So either one would be acceptable. Okay, you could say 12 over 5 or 2.4. Either one, because they're both exact. That decimal does not go on forever. But please make sure you label its radians. This angle is always in radians. Okay? All right, these applications, it's kind of real life thing. I'm going to do the first one with you, but the rest I'm going to have assigned. So you're going to do those on your own. All right? Let's start with this number 1 here. A dog is attached to a 10-foot leash and travels around an arc that has a length of 25 feet, which represents the radian angle he has rotated through. This is where people are like, I can't do it. You can. Okay. There's a spike that ties in the dog's chain. Here's the dog on his leash, okay? Arf, arf. Sorry about the dog. He's not that bright or attractive. Now, it's a 10-foot leash. Okay, he runs around. He chases the mailman. One day he just dreams about sinking his teeth into the mailman's calf. I'm going to bite you. Okay, that's the sector. All right, that's the sector they're talking about. This is the angle. Okay, he says this arc length that this dog is running is 25 feet. Sorry, I had to do that one more time. That's 25 feet. They want to know the angle the dog runs through. S equals theta times R. It doesn't change. Okay? We have the 25 for our sector, or our arc length, I'm sorry. We need to find the angle he runs through times 10. Just divide by 10. 2.5 radians. That's the angle. Let's do a few more of these. Maybe I'll give them a separate homework sheet. A wheel whose diameter is 3 feet. Okay, 3 feet diameter. The whole thing is 3 feet, which means one radius, which is what we need, is 1.5 feet. I'm sorry. I wrote the answer down, but I didn't circle the answer here. Oh, I'm getting like my students. Nothing drives me more crazy than having to work and not like writing the number on the space that you chose or filling in the bubble or circling the answer. Drives me nuts. Anyways, here we go. Okay. The wheel has a diameter of 3 feet and rolls a distance of 45 feet. That means it rolls the surface, whatever. It rolls around 45 feet, okay, without slipping. What radian did the angle rotate through? So the arc is 45 feet that it rolled through. So S equals my angle times radius. They want to know the angle. Well, if my radius is 1.5 and it went 45 feet, I just divide. Gosh darn it, y'all. And I believe that's 30. 30 radians. Make sure you label. And better yet, make sure you do this. Look what they do here. Look what those crazy people. It's like it's radian, so you think it needs a pi. Radians doesn't always need a pi. Okay? It doesn't always. A pi was not given to us here. We're not, but it's a circle. Shouldn't there be a pi? No, stop it. If you're given the pi, you use the pi. You're not given the pi here or here, are you? No. Then why would you just put one in? For poops and giggles. Haha. No, stop it. No pi. 3, and I hope you pause these videos to see if you can do these on your own. If you haven't, try and do 3 and 4 on your own. And I like really drawing things. Okay, number 3. The distance from the center of a Ferris wheel. Ferris wheel, center, to a person who is riding, little box, little dude in there, hey, how's it going? 38 feet. Okay, that's your radius. What distance does a person travel if the Ferris wheel rotates through 4.25 radians? 4.25 is my radians. What distance does he travel? We are finding the S. S equals radians times radius. So that is 4.25 times my 38 feet. Oh, 4 times 38, that's 2, carry the 3, 12. Oh my God. 152, then a quarter of that. Let's do that in here. 152 and a quarter of 38, but let's just do 38. Let's turn this on first. 38 times 4.25, which would be more than 152, and it is. It's 161.8.5. I'll be okay. Bang. That is 161.5. That's feet, because that's the label they gave us, all right? Oh, what feet. Look at that. Nice. Nice. Okay, even without a calculator, I know 4 times 38 was 152. Plus, I got to have a little bit more, so I knew it couldn't have been this or this. And I know that's way too much. So we could have ballparked that and got it. Good for us. Good for us. We're getting smarter. We are. Okay, on to the last one. Oh, golf. A golfer swings a club at about a pivot point. Okay, so here's a golf club. Mine are Callaways, but it's a golf club. Okay, here's the pivot point. It swings around this pivot point. So it's going. I think you understand. There's a pivot point. Okay, swings about a pivot point. If the head of the club travels 26 feet, 26 feet, that's the arc it makes. Okay? Yeah. And through an angle of 5 radians. Which of the following gives the distance the club is from the pivot point? Finding the radius. If the distance of the arc equals your angle in radians times your radius, 26 equals 5 times r. Divide by 5. Divide by 5. That is going to be 5.2, I believe, because you get 5 and 1/5. It's 0.2. And that is in feet. That's a club. That's 5 foot, that club at 5.2 feet. Oh, my goodness gracious. That's a big golf club, y'all. But you know what? Maybe it's like a Shaquille O'Neal's golf club. That's fine. That's fine. That works. Okay? We have done this. This is fun. This was easy. I like this lesson. Don't get too used to it because we're going to get a little crazy with trig in a little bit. All right? I will see you for Unit 3, Lesson 4. Adios.